All right, my friends, let's get started. So to write your fraction in mixed fraction form, you could get started just by setting up some long division. In this case, I think long division would make the most sense since you are not dividing by a linear factor there. Okay, so let's start by having a 2x up here. Since when you distribute it in, it would make that front term drop out. So go ahead and distribute fully, and then make sure you subtract the whole row. Okay, and then do the process again. So x squared times -1 this time would make this front term drop out. And then we'll subtract the whole row. Let's see, what are we left with here? -2x plus 5 for your remainder. And you can tell you're done with this process when the degree of what's left is less than the degree of what you're dividing by, because the whole point was to have a proper fraction in your answer. So at this point, I could say that this fraction is equal to 2x minus 1. You could say minus, or in this case, I think I'll go ahead and say just plus -2x plus 5 over x squared plus x minus 2. Now, at this point, I have not, decomposed anything. So when the directions say write the partial fraction decomposition, what on earth are they talking about? Well, I hope it makes sense that they're talking about the remainder here. And so, I'm just going to do the partial fraction decomposition on that part, and then I'll bring the whole thing together for my final answer when I'm done. So -2x plus 5 over x squared plus x minus 2. Step 1, factor the denominator. And then we've got a distinct linear factors case here, so the form is fairly straightforward, just constants over each factor. Then we'll switch gears to adding the fractions together. So a over x plus 2 would need to be multiplied by x minus 1 over itself. And b over x minus 1 would need to be multiplied by x plus 2 over itself. There we go. Follow your distribution nose. There we go. Okay. The whole point was to get something that would add together and equal this fraction that you started out with. Notice that we have won the denominator battle, and now we just need to win the numerator battle. So I'm going to set the numerator from the fraction on the left equal to the numerator and the fraction on the right. I'm just going to regroup things. So I'm going to group the x terms together and factor the x out on the right side. And then I'm going to factor the group the non-x terms together as well. Okay. From there, if I want the polynomials to equal each other, then I would need a plus b to equal -2. And then I would need -a plus 2b to equal 5. Okay, I like to solve this particular system of equations just by adding the rows together, since I already have perfect opposites there with the a terms. So I'd end up with 3b equaling 3, which means b would be 1. And then let's back substitute maybe into row 1, and you could kind of eyeball it. It looks like a would end up being -3, I think, if b is a 1. I think so. Okay, so now let's try to remind ourselves, what were we doing? So we can take these and put them back into the form, but then also keep in mind that we were really only decomposing the remainder. So our conclusion would be that 2x cubed plus x squared minus 7x plus 7 over x squared plus x minus 2 breaks down to be 2x minus 1 for that kind of real number part, and then the remainder decomposes to be -3 over x plus 2 plus 1 over x minus 1. There we go. All right, my friends, I hope this is making sense, and I hope you're willing to ask questions for the part that doesn't. Take care, everybody.